Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Volumes of Familiar Solids, Cones, and Cylinders. Okay, so Lesson 10 is going to talk about volume. That is a three-dimensional figure. Volume is length, width, and height, so we're going to have cubed values. Write an equation to determine the volume of the rectangular prism shown below. So, for starters, if we wanted to find the area of the bottom, area is length times width. So write an equation to determine the volume of this. It would be volume equals length times width times height. So the equation for the volume of this is length equals 8, width equals 6, and the height equals h. So when I do the calculation and simplify, 6 times 8 is 48 h millimeters cubed. Okay, so that is the volume of that rectangular prism, 48h. Number 2, it says write an equation to determine the volume of the rectangular prism shown below. Okay, so now we're going to write the formula again. V equals length times width times height. Volume equals the length, 10, times the width, 8, times the height, h. So volume equals 8 times 10 is 80, times the height, inches cubed. Don't forget that these are all cubics. Whenever you see the word volume, it's going to be something to the power of 3. Length, width, and height. Okay, number 3. Write an equation to determine the volume of the rectangular prism shown below. Volume equals length times width times height. Volume equals length times width times height. So the volume equals 24 times the height, centimeters cubed. Okay, part 4 says to write an equation for volume V in terms of area of the base. So we have V equals. Now what they're talking about here is, if I go back to these last 3 examples, get them so that you can see all 3. What did we do each time? Well, we took the base area, which I marked in red in all of these, so I didn't finish these because I was just doing length and width. But if I close those off, then it's the floor of each of these boxes. That's the base. And the length times the width is the base, and then we multiply by the height every time. So all we really found in these 3 examples was the surface area, or the area of the bottom. So 6 times 8, 8 times 10, and 4 times 6, those are all the base. So that is our B. So in other words, this volume equals length times width times height. The L times W, which is your base, we can replace with B. So I can say B equals length times width. And that's what we're leading up to in this next example. So if I said volume equals length times width times height, like we've always been doing, and now I know that B base equals length times width, then I can simplify my equation and just say it is B, the base area, times the height. Okay, so we're going to use that now to do part B. Using what you learned in part A, write an equation to determine the volume of the cylinder shown below. So start off with a formula. V equals B times H, where B is the base area and H is the height. Well, what is this shape of this base? Well, if I look at this, obviously it is a circle. So the area of a circle is pi times the radius squared. So that replaces my B. So now I'm going to multiply that by h. And then, now that I have the formula, I substitute in my givens. Radius, 4 centimeters. So it's pi 4 squared h centimeters, so it's just times h. So the volume of this cylinder is 16 pi times h centimeters cubed. It did not say to approximate pi, so we aren't going to use 3.14. We aren't going to use 22 divided by 7, and we're not going to use a calculator with a button that represents pi. Whenever it doesn't say, all you do is solve in terms of pi. And the answer is 16 pi times the height centimeters cubed. Okay. So now exercise 3, 1 through 3, is asking you to do these problems. So pause the video, see if you can do these problems with the 2 examples that I've done, and pause the video, and when you're done, unpause it and check to see how you did. Okay, so assuming you've done these, here we go. Use the diagram to the right to answer the questions. What is the area of the base? Well, the base is this portion here. The box, the bottom of the box that's sitting on the floor, that is the base. Okay, the resolution isn't the best in my projection here, so I'll write these in. This is 4.5 inches. This one says 8.2 inches. And this one is 11.7 inches. Just in case that's hard to read. Okay, so use the diagram to the right to answer the questions. What's the area of the base? Well, the area of the base is going to be represented by the letter B for base, and it equals length times width. So always write a formula first. Substitute in the givens. The length is 4.5 inches, and the width is 8.2 inches. So the base is the product of these 2 numbers. So I'm trying something new here with this calculator. So I found out how we can just show the LCD image. So here we go. So I want to multiply 4.5 times 8.2. 4.5 times 8.2 equals 36.9. So the answer to this is 36.9 inches. And since it's area, it's squared. Area. So if I wrote inches times inches, well, it's inches squared. Anything times itself is the same thing as it being squared. Then it says, what is the height? Well, the height is right here. So that is 11.7 inches. So I'm going to say h equals 11.7 inches. So now the final question is, what is the volume of the rectangular prism? So volume equals the base area times the height. Okay, so we're going to solve this. So V equals B. B is 36.9. So I write 36.9 times H. H is 11.7. So it's times 11.7. So multiplying that, get the calculator back out. And now I already have the 36.9 on my screen, so now if I just hit times 11.7 and hit enter, then I get 431.73. So that's 431.73 inches cubed. Okay, now number 2 says to use the diagram to the right to answer the question, what is the area of the base? Now keep in mind that if we have a cylinder, the base is on the bottom, but in this case they gave the information up above. But if it is a cylinder, like they told us, then the base and the top are equivalent. So we can use this information here. So the area of the base is B equals, and it's a circle, so it's pi r squared. Always start off with a formula. Then B equals pi times the radius, 2 squared. So the base is 4 pi centimeters squared. Area squared. Okay, now it says, what is the height? Well, the height is right here. And the height is 5.3, I believe that says. Yes, 5.3. So the height is 5.3 centimeters. So then it says, what is the volume? So volume equals your base area times your height. Okay? So we write the formula, we substitute in the givens, and B is 4 pi centimeters squared. I'm just going to write 4 pi for now, and I'm going to multiply by H. And H is 5.3. So my volume is going to be 4 times 5.3. 4 times 3 is 12, carry the 1. 5 times 4 is 20, plus 1 is 21. And there is one decimal place, so it's 21.2 pi centimeters cubed. Remember, it's volume. 21.2 pi centimeters cubed. Okay, number 3, what is the area of the base? So B equals, I look at this, the base is down here, there's no information, but the base is also equivalent to the top, and that is a circle with a diameter of 12. So you need to realize that if I have a diameter, then the radius is half. So if D, let's use a lowercase d, if the diameter equals 12 inches, that means the radius is half of that, or 6 inches. So we needed to do that first. So my B is a circle, pi r squared. So B equals pi times 6 squared. So the base is 36 pi inches squared. Remember, area squared. The height H equals, the height is this side here, its length is 25 inches, so I would put 25 inches. The volume of the cylinder is base. Let me keep going with the colors. The volume of the cylinder is the base times the height. So the volume is 36 pi times 25. Simplifying, we get 36 times 25. Get my calculator. And start over. 36 times 25 equals 900. Okay, so I'm going to write in 900 inches cubed. Remember, it's volume. Okay, exercises 4 through 6. It says to use a diagram to find the volume of the right circular cone. We haven't done area or volume of a cone yet, so I have a video that I want to show, and let me go get that. Okay, so here's the video.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water.
Okay, so back from that video, now you know that the volume of a cone is, the volume of a cone equals 1/3 the volume of a cylinder, which is pi r squared times height. Okay, so we now know that there is 3 cones to fill the cylinder. So the cylinder is 3 times the cone, or the cone is 1/3 of the cylinder. So now we're going to use that formula. Use a diagram to find the volume of the right circular cone. So volume equals 1/3, and it's the B times the H again. But in this case, the volume equals 1/3 the base, and the base is pi r squared, by the way, so it's 1/3 pi r squared times the height. Volume equals 1/3 pi. The radius is 4, so that's going to be 4 squared, and the height is 9. Okay, so simplifying this, 1/3 times 9 is 3. So then I can say the volume equals 4 squared is 16 pi millimeters cubed. Okay, so there is the answer. 16 pi millimeters cubed. Okay, but before I forgot my 3 here, so let me just quickly fix this. Okay, so what I was saying was the volume equals, I did the 16 pi, but I forgot this 3 that's still there. So the volume equals 48 pi millimeters cubed. Okay, sorry about that, but there it is, 48 pi millimeters cubed. Number 5, use the diagram to find the volume of the right circular cone. So again, we're going to write the formula. Volume equals the base area, actually 1/3 of the base area times height. Okay, so volume is going to equal 1/3. The base is a circle, which is pi r squared, times the height, which is here. Okay, so the volume is going to equal 1/3 pi. The radius is 2.3 squared times the height, which is 15. Okay, the 1/3 and the 15 reduce to 5, and we get the volume equals 2.3 times 2.3 is the calculator. 2.3 squared is 5.29, so it's 5.29 pi times 5. Don't forget this 5 like I did last time. So the volume equals 5 times 9 is 45, carry the 4, 5 times 2 is 10, plus 4 is 14, 5 times 5 is 25, plus 1 is 26. So it's 26.45 pi meters cubed. Okay. Okay, number 6. Challenge. A container in the shape of a right circular cone has a height of h, which is here. A base of a radius r is here, as shown. It is filled with water in its upright position to half its height. So that's where they're telling you right here. That's half the height. Assume that the surface of the water is parallel to the base. So the water, it's not tipped, of the inverted cone. Use the diagram to answer the following questions. A, what do we know about the length of AB and the length of AO? So what I would say was the length of AB, which means the absolute value. Length can't be negative, so we use those absolute value symbols. The length of AB, well, that's our radius. So the length of AB equals R. And they're asking about the length of AO. AO is right here. Well, that is our height. So the length of AO equals our height. Okay, B says, what do we know about the measures of angle OAB? So here's O, here's A, here's B. OAB is right there. And angle OCD, which is right here. Okay, so the measure of angle OAB equals the measure of angle OAC, and they are both equal to 90 degrees. In other words, they're right angles. Part C. What can you say about triangle OAB? So now we're talking about triangle OAB, so let me erase this. Okay, the triangle OAB, let me do that in purple. This is triangle OAB right here. And OCD. So OCD is right here. Well, from prior lessons, if we know that this is 90 degrees and this is 90 degrees, and angle AOB and COD are the same angle, that means we have two angles that are congruent. And since we have two angles congruent, then triangle OAB is similar to triangle OCD by angle. Okay, D. It says, what is the ratio of the volume of water to the volume of the container itself? Okay, so when we see the word ratio, well, ratio means a comparison of two things. So I want to compare things. So AB is a radius, CD is a radius of the surface of the water. So I would say AB is to CD as, and AO is a height and CO is a height. So AO is to the length of CO. Okay, and we also know that AO, this whole thing, since CO is half of it, AO equals 2 of the COs. Okay, so in other words, if CO is half, it would take 2 COs to make the AO height. Okay, so then we can simplify this and say, and since I can replace AO with 2 CO, then now I can say the length of AB is to the length of CD as, instead of putting AO, I put 2 CO is to the length of CO. Okay, so then we can conclude that AB, the length of AB equals 2 CD. Okay, so in other words, what we're saying is if AB is to 2 CO and CD is to 1 CO, then AB is to 2 CD. All right. Okay, hang on for this ride. This is might be a little confusing. So now if we say the volume of a cone is 1/3 the base times the height, and I substitute in the volume is 1/3 pi r squared times height, then I substitute in 1/3 pi, and the radius of the big triangle or the whole cone is AB, the length of AB squared times the height AO. Okay, and then by substituting AB with 2 CD, like we know that AB is to 2 CD right here, now we can replace that. Then we now have the volume equals 1/3 pi. Now we're replacing AB with 2 CD. So here's what's happening here. 1/3 pi AB squared. AB is my radius, but it's 2 CDs. So length of AB is twice the length of CD. So I can replace AB squared with 2 CD squareds times OC, which is the height of the smaller triangle, or smaller cone, I should say. And that is 2 CO. Okay. Now we're going to substitute in. Okay, so now you see this 2 here. Well, 2 squared is 4, and then there's another 2 over here. So 2 squared is 4 times 2 is 8. So I can bring that 8 out in front and then put 1/3 pi, and then it's just going to be CD left because this 2 is now out front. So this is now CD squared times CO. So that just showed that the volume of one, the original one, is 1 to 8. Okay, so the volume of the containers is, the ratio of the volume of these two containers is 1 to 8. Okay, that is the end of lesson 10. Review the lesson summary and go do your problem set.